9 o'clock, so let's start. I am Björn Fahller, and I'm going to talk to you about using Trompeloeil, a mocking framework for modern C++. A bit of background before I start. I work in Stockholm for a company named NetInsight, where I develop embedded software for communications devices in modern C++. Trompeloeil is not my job. It's a hobby project. A guy has to have hobbies, plural. This is one of them. I've been working on it for about 3 years, I think. I don't remember exactly when I started. Trompeloeil is used at NetInsight there. And it's kind of cool that they let me travel and talk about my hobby project, I think. This is a known fact. Long time ago, I was a teenager. I had a summer job here in Oslo. Who would have known? Worked for the Norwegian Geotechnical Institute. That was before I was into computers very much. Trompeloeil. The name is always an issue for surprising reasons. Here's what a concise encyclopedia says. Trompeloeil is a style of representation in which a painted object is intended to deceive the viewer into believing it is the object itself. So Trompeloeil is an art form, a visual deception. Literal translation is trick the eye or deceive the eye. This actually makes sense from a testing perspective, a mocking perspective, because when you write unit tests, you want to test your unit in isolation. Cutting off all dependencies. This is trivial if it is a leaf class that doesn't have any dependencies, but if it has a lot of collaborators, you don't want to involve them too in your test. So you replace them with mocks. You deceive, if you like, the object being tested into thinking that it's operating in a world that looks the way you have described it in your test. So when you write your test code, you're in effect painting a picture for your unit being tested, and you verify that your unit behaves according to that picture. So I think the name Trompeloeil makes a lot of sense for a mocking framework. Some examples of Trompeloeil art. This is what you get if you go to Wikipedia page on Trompeloeil. For some reason, they do not mention mocking frameworks. If you search hashtag Trompeloeil on, say, Instagram or Twitter, you'll find a lot of street art. Also some finer art like the boy escaping from the frame. And some are amazingly subtle. I really like the portrait to the right. I don't know if you can see the fly that is painted on the frame below the portrait. That is great. When it comes to mocking in C++, there are basically two schools of mocking frameworks, because there's one thing that C++ does not have that most other languages does, and that is reflection. So one school uses knowledge of how to interpret debugging data compiled into your binaries to find out how the data structures are laid out. A popular technique from there is to create their own vtable representation, redirect the vtable pointer to their vtable, and then you can intercept any calls you like. Very handy. From a C++ language perspective, that is so undefined behavior, it's difficult to imagine. The other technique is to work within the language, and then you have to compensate for this lack of reflection in other ways, and typically that is done by the preprocessor. So they're macro heavy. Trompeloeil belongs to the latter kind. It stays true to the language. To the best of my knowledge anyway, there are no deviations or any undefined behavior. It's C++ 14. It's implemented in a single header file. It's about a little more than 3,500 lines of horrendous macros and template black magic. It's on the Boost license, so at least from a legal perspective, anyone should be able to use it if they want to. It's available from Conan, the package manager. And it's adaptable to any unit testing framework, at least I think it is. This adaptation is important. If you go to the GitHub page and you scroll down below the source code, you find this documentation. The first link is integrating with unit testing frameworks. When you click on that, you see this text that says that by default, Trompeloeil reports violations by throwing exceptions. Many mocking frameworks do that, but I find it to be a little bit troubling. That's why I strongly suggest that you use an adapter for your unit testing framework. Because if you think about it, your mocks are, by definition, called by your unit being tested. So if they throw an exception, that exception will flow through your code that is being tested. So at the very least, this puts a constraint on your code that you really, really, really shouldn't catch that exception, because then you have sort of defeated the whole purpose. Below this description is a list longer than that one with some popular unit testing frameworks. You click on it, you get a code snippet of 10, 15 or so lines that you copy-paste into your test program, and then you're done. If your favorite unit testing framework isn't listed, please write an adapter. It's not difficult, and it is documented how you do so. And when you have done it, please submit a pull request to documentation in the cookbook so that others can take advantage of that unit testing framework too. I'm going to tell you about how you use Trompeloeil by following an example. In 2004, Martin Fowler wrote this blog post, Mocks Aren't Stubs. The idea behind that blog post was to set the terminology straight. What do we mean when we talk about fakes? What do we mean when we talk about mocks? What do we mean when we talk about test doubles in general? But he used an example in that blog post that was a whiskey store. And you're to implement an order class. And the order class uses a store. And to be able to write tests for the order class, we mock the store. So back to Trompeloeil. How to mock something. You begin with writing a source code file, and you include trompeloeil.hpp. When that compiles, you have really done the most difficult part. You have spelled it correctly. And then you introduce some type, in this case a struct named myMock, and what you want to mock. The only thing you can mock in Trompeloeil is member functions. So this make mock1 func and the function signature means this. Are you familiar with Google Mock, by the way? Some people are nodding. Yeah. This should look quite familiar. It's the same idea. I could have chosen the same macro name, but I elected not to because that could be confusing. So you have make mock, a function name, and a signature. And the 1 in make mock1 is because the number of arguments to this function is 1. So this makes a mock implementation of the function func that takes a string or value reference and returns an int. I found that many mocking frameworks, even today, have difficulties with some modern constructions like R-value references or move-only types like unique pointer. Trompeloeil is not one of them. It's written in C++14 for C++14. A problem with this approach, though, is, oh boy, who has not made this mistake? So, you know the drill. You have template code with horrendous constructions hidden behind macros. You get 1,000 lines of completely incomprehensible garbage like that. Function signature does not have 2 parameters in make mock2. Okay, that is comprehensible. And that is the full error message from D++ 5.4. I've made quite an effort to trap these easy to make mistakes and make sure that you get a helpful compilation error message that directs you to what is wrong and gives you a short message that does not have a lot of unrelated nonsense. In fact, there is a test suite of currently 37 test programs that do not compile, and I ensure that they fail in an expected way with good information. Back to this. One very common seen idiom in writing tests with mocks is that you implement to an interface, a pure abstract base class. This, of course, works well. It's not by any means required. I will show that later on. But when you do, please add override. It will save you a lot of headache. And here, by the way, is that code duplication that I mentioned in the beginning that we need because of the lack of introspection. It really shouldn't be necessary to say make mock of this function because it is already known by the interface, but the language is the way it is. I don't think that this is a horrendous problem. There are other things that are more important, but this is a drawback, and there's currently no way around it given the way the language works if you want to stay within the language. Back to Martin Fowler's example. Here's the example that he used. His example was, of course, in Java, but the idea is the same. So I will start with following his example more or less exactly, and then I will start improvising around it, deviating as we go. So his idea is that we have a store, we can query its inventory for an article, and we can remove some quantity of an article from the store. And then we have an order class where you can add certain quantities of some article as you wish, and then you can fill the order with the store. So a usage could be like this code snippet here, where you have an order class, you add 50 telescopes. That is actually his example. I guess he really likes his whiskies, his telescopes. And then you get a store from somewhere and you fill the order. So doing this in Trompeloeil, we create a class Mobstore that inherits from the store. Make const mock. I didn't mention that one. Const is for making a const member function. The name and the signature, and override since we're implementing to an interface. And make mock 2 for remove since it has 2 parameters. And then we can write tests. In this example, I'm using the catch unit test framework written by Phil Nash. You can talk to him down in the JetBrains booth if you want to. He's also talking later today. In catch, my usage of catch is actually quite naive in here. He will tell you a lot more interesting things. But for these examples, all you need is a test is expressed by saying test case and a name as a string. And then you have the test body. So here I have a test case. Filling does nothing if stock is insufficient. So we create an order class, order object. We add 51 telescopes to it. Get a Mobstore. And then we place an expectation to say that I want inventory to be called now with whiskey. And what happens here is, to begin with, the reason we can place this expectation is to begin with that store is of a mock type, or rather that inventory is a mock function in a type. And that it is possible to call store.inventory with whiskey, because whiskey is a const char star, and const char star can be implicitly converted to a string, so this works. And you can make an equality comparison to see that they are the same. This creates an expectation object right here in this scope. It doesn't have a name that you can know, but it is a local object. And this parameter whiskey is copied into that object. So if you change the whiskey variable to point to something else, this will not matter. It has its own local copy. If you want to have a reference to it, just call it with studref, and then it works equally well. This expectation object is placed first in the list of expectations for the inventory function in that type, in that object. And this expectation must be fulfilled by the time the expectation object goes out of scope, or is destroyed, which it is when it goes out of scope. And here is where Trompeloeil may need to report errors during destruction, because the expectation object is destroyed. It sees that, wait a minute, this expectation, this requirement is not fulfilled. Violation, report. So that is also one of the reasons you really want to use an adapter for your unit testing framework to report errors, because throwing an exception in this point is, it's to terminate. So let's make the smallest possible implementation of order that actually compiles. And it didn't compile. Blimey. Return missing for non-void function. Yeah, that is the full error message. There's nothing else. Many unit testing frameworks just return a default in this case. I found that being explicit, requiring you to say what it should return, does reduce number of WTFs over time, because the code is much more explicit. It may increase the frequency of WTFs early when writing the code, but after half a year when you make a change, you're really happy that it is explicit. And I've actually seen errors that were hidden because it wasn't obvious what the test code actually did require. So we add a return 50. 50 here is actually any expression. You can write, well, whatever you like, as long as the type of the expression is convertible. You could call random, probably a really bad idea, but you could. So with this change, we can compile it, and it fails at runtime, obviously, with the message expected store.inventory whiskey to be called once, actually never called, which makes sense because the implementation of order was just nonsense. So let's improve the order class such that it remembers the article, and when we call fill, it actually calls inventory, and that works. So let's write another test. Filling removes from store if in stock. I'm still using Björn Fahler's example, by the way. So here we have exactly the same as before. Place an expectation, a requirement that the inventory is called, return 50, and a requirement that remove is called. You may note now that these two are added to separate lists. There's one list of expectations for inventory, and there's one list of expectations for remove. So from Trompeloeil's point of view, these expectations are logically parallel. We don't care if inventory is called before remove or the reversed, which often makes sense, but in this case it's kind of weird, isn't it? So we can change that. We can add a sequence object to impose an order. This is more or less exactly the way that Google Mock works, by the way. So you have a sequence object, and you, for every expectation where the order is important, you say in sequence and the name of the sequence object. And the way this works is that the sequence object must see events in the order they appear in these in-sequence modifiers. And you can have several sequence objects if you like, if you want to describe sequences that are themselves important but are logically unrelated to each other. And you can also have several sequence objects in one .in-sequence modifier to sort of join them and say, here is a common point, and then they can split again. So by doing this, we have ensured that they are called in the proper order. The test fails because we haven't implemented the call to remove. So let's do that. Remember not only the article, but also the quantity and ensure that when we call fill, it calls remove, provided that the quantity returned was sufficient. And everything works. Yay. So that was Martin Fowler's example as far as he took it, because his only intention was to show what do we mean with a mock. And that shows rather well here. But let's expand. I'm a bit troubled by this interface, really. This API doesn't work at all if you have several orders that are working in parallel to one store, perhaps over a network. You have arrays on inventory and remove. What if we want different types? Maybe we should think a bit more generic. Strings as articles are really good for testing. It makes everything clear, but perhaps the real implementation will want to use some other type. And do we really want an object-oriented design that feels like 1990? Let's do it a different way. Let's work with concrete types, templatized on the article type. And we have a reserve that just say, I want 50 Taliskers, and it says, you got 20, sorry. And if you're really disappointed, you just cancel those 20, because how much fun is just 20 Taliskers? Or if you're happy with it, yeah, remove 20 Taliskers from the store, that's fine. And a convenient type alias for the test. You may note now that we're mocking a class template. Some mocking frameworks have trouble with this. Others use different syntax just because it's a template. Not here. It's all the same. And to reduce typing a little bit, let's create a record type that has both article and quantity, because we always work with them as pairs. So now we can see a slightly different use situation where we have a store from somewhere, we create an order object that refers to the store, and if the return value from add is what we wanted, then we fill the order, otherwise we just give up or something. Order something else, whatever. So let's write some other tests. Add returns a reserved amount. So I create an order object from my mocked store, and I place a requirement that it's called with a record of 51 Taliskers. This won't compile because there is no equality comparison operator for record. I could implement one, but less fun in that. So instead, use the underscore wildcard. In namespace Trompeloeil, there is the underscore. It's a matcher for any value of any type. So you could use this for a unique pointer or value reference or whatever. Works fine. So we place a requirement that reserve is called with anything, which is not really very useful. But then we can constrain it and say with. I guess that should really have been when, but well, made a mistake, I guess. And then we have a Boolean expression that describes the constraint. One thing you see now is underscore one. Underscore one, in with here, in this expression, you refer to the parameters of the call by their positional name. So underscore one is the first parameter. Underscore two would be the second if this had two parameters. Now underscore two is a compilation error. But that way you can build up or express whatever you like in there using the parameters to the call just by their positional names. And you can call functions in there, which is actually implicitly done here because we're comparing string article operator equals const char star in here. And then at the end, I use a a catch assertion. So this is not a Trompeloeil thing. This is a catch assertion to see that the returned value is indeed the one it should be. Otherwise, the test fails. So implementing the order class template, which is now templatized on the store type. The constructor remembers the store, and the add function calls reserve and returns whatever we got from there. And this works. You may notice that I cheated now and didn't show you the failure, but you've already seen those, so nothing new there. So we can create yet one test. Fill removes the reserved item. So the first part is exactly the same as we saw before, no difference at all, but then a second scope with a requirement to call remove. This is an anatomy that is very typical of tests written in Trompeloeil. If your test involves several steps, you get one local scope per step where you set the requirements, expectations for what should happen in this step first, and then a trigger event. And then a new scope with its requirements and the trigger event. And this is also one of the reasons that sequence objects are really usually not needed. There are situations where they are absolutely necessary, but often you just get this natural sequencing by these scopes. If you have very many of these, you probably have a design smell, but also code with foul smells needs tests. So there you go. In this case, I place a requirement that remove is called with 50, even though we call add with 51, because in the first step, the reserve call returns 50. So we ensure that it is remembering the right thing, remembering what was returned from reserve, and not remembering what we asked for. And doing so, I need to improve again the order class a bit. I have an unordered map of reserved items, and I ensure that add saves what the result was. And then fill just traverses the items in reserve and calls remove on them. And this is, of course, just fine. So we have more tests. Destructor cancels the items. You may have noticed on the previous slides that I cheated and actually leaked memory because I didn't want to run the destructor. Debatable technique, I know, but again, the same first scope, identical, and then just expectation that cancel is called and reset to run the destructor. Nothing new. Implement the destructor, and everything works. This is getting a bit boring. Multiple adds to the same are combined, so we have one scope for the first remove and one reserve, and one scope for the second reserve, and this is nuts. There's so much repetition. We're doing the same. I hate that. Absolutely hate that. One possible way to do this, get away from it a little bit, is to say allow call instead of require call. Allow call is anywhere between no calls at all and infinity, or, well, unsigned long max. I guess we can approximate that with infinity. And we just return whatever was asked for. Then we can have two calls to add right after one another. Perhaps allow call isn't great. Perhaps it's better to say that I want this to be called exactly twice, because we know we make two calls to add. And just for completeness, you can say at least twice, or at most 5, or even anywhere between 2 and 5. I've actually never once used that, but I'm sure if I remove it, someone will complain. I guess there is a need, maybe. And then the requirement to remove these 50, because 50 is the sum of 20 and 30. And that should have worked, shouldn't it? And what is this hex dump? When Trompeloeil must report an error for a type, it checks, is there a print function in namespace Trompeloeil that matches this type? If it is, it's used. If not, it checks, is there a no-stream insertion operator? If so, it is used. If not, it checks, is this a pair? I know how to print pairs. Left curly, first comma, second, right curly. If it's not a pair, is it a tuple? If it is a tuple, left curly, element, comma, element, comma, element, comma, element, right curly. If it's not, is it something that has begin and end? If so, left curly, element, comma, element, comma, element, comma, right curly. And it does this recursively. So if you want to print a map has a begin and end, so left curly, element, comma, element. Every element is a pair, so left curly, element, comma, element. And such a list, so you get everything. And if all that fails, it does a hex dump of the memory region occupied by the object. And of course, everybody can read Talisker there in yellow, can't you? So this uses a short string optimization for a std string. Let's write a print function. Small thing, just in namespace, Trompeloeil, print that takes a no-stream reference and your type, and do something that makes a little bit more sense. This can actually be useful even if you do have a no-stream insertion operator, because there might be information, say if your object has some cache. That cache may be important in test to understand what's happening, but it may not be something you normally want to write. So with this, we see instead this failure, that it was an unexpected call to remove 30 Taliskers when there was an expectation to call remove 50. All right? That was embarrassing. Okay, easy to fix, and everything works. I think still that there was an unhealthy amount of repetition in the tests that I wrote. So I want to be able to express a Mobstore on a higher level that has some intelligence on how to behave. So I want to create this Mobstore and say, this is the stock of whiskies that it has. And as long as calls are made to it within the rules, I'm all right with it. And if calls are made outside the rules, report it. And this doesn't have to handle every possible situation, because the odd situations we can still handle exactly like before. But if it manages the bulk of important situations, then we can save a lot of code repetition, things that are tedious if we actually want to make a change that affects several tests. Obviously, it's not required to handle several parallel orders, because it's not it is the order class we are testing itself, not the mock. And I think it should suffice to have an object that keeps track of what the stock is and manipulates it, and has a map of what is reserved by the order class. So we can manipulate these maps. And then it also has the required expectations, so we know what is allowed and what is not allowed. So how do we do that? I can have a stock with reserved type that takes a mock store, and a stock, and has these maps. But how do we handle the expectations? Allow call is no good, because it must be fulfilled by the end of the scope, and that is when the constructor runs out. We don't have much use for that. There is named allow call. Named allow call gives a unique pointer to a Trompeloeil expectation. So now we can bind that expectation to something, in this case a member variable E at the bottom. So now this expectation stays alive as long as our stock with reserve object is alive. And then I can refer to the member variables in the with constraint. So I say that as long as it's called with a quantity that is greater than 0, because we don't want to call reserve nothing, that doesn't make sense, and called with something that is in stock. We handle out of stock situations differently in other cases. And as a side effect, when this happens, we manipulate the store. decrement the available stock and increment the reserved quantity, and return what was asked for. And with this, I can write the test differently. I'll say stock with reserve, 50 tileskets. That is all we have in this store. And I can refer to the store in I can refer to the reserved items in the constraint. Now, LR here is an intentionally ugly thing. It is a construction similar to the C++ cast. They are ugly because they are a visual warning. Local reference means that they refer, every name referred to in this constraint that is a local variable is actually referred to by reference. So there may be lifetime issues here. So we must ensure that the variable s lives at least as long as this expectation does. In this case, it's perfectly safe. Require call is destroyed. The expectation object for require call is destroyed by the end of this local scope, and s is in an outer scope. So it's perfectly safe. So we can do that. And yeah, I guess I just exposed a little bit of what happens under the hood here, that this macro expands into a lambda expression, among other things. And this LR changes the capture to be a reference capture instead of a copy capture. So a little bit of a crack here in the facade, I guess. But there you go. This works fine. If we're a little bit on the paranoid side, we may be worried that maybe, for whatever reason, fill calls reserve. Reserve is allowed to be called because we have an expectation on it from this stock with reserve object. I can override that by explicitly saying forbid call. This must not happen. This creates another expectation object. It is placed first in the list of expectations for call to reserve. And when there are several competing expectations for the same call, they are tried in the order they are found, tried in the list, in the reversed order of creation. So this forbid call was created last, therefore it's first in the list. And this one is completely unconstrained. It matches anything, and it is forbidden. So if there is a call to reserve here, we will get a failed test. So that is good. And this is also a pattern that I've found useful, perhaps not necessarily with forbid call, but that you can early in your test, and perhaps in a test fixture, you can set up a default behavior for how you want something to act. And then in a local scope, you can override that and say, in this context, I want it to behave this way instead. For example, this allocation call will fail or whatever. Perhaps a better way, though, is instead to just let our stock with reserve be on a narrower scope. This means that we obviously cannot refer to the map called reserved in here because it's dead and gone. A matter of taste, I guess. I've been told kittens make presentations better, so there you are. So we want to be able to order several whiskies. So we stock up with both Taliskers and Oban. Add a few of both. And then we want to ensure that what is removed when we call fill is exactly what is reserved for each of them. So I have, again, the LR width to ensure that it is the expected quantity and that it exists there to begin with. And as a side effect, I remove it from the map. Probably better, again, to not use allow, but to say ×2, because we know that there are 2 whiskies in there. And perhaps I should have added a requirement, an assertion that after this, then this map really should be empty. I should have erased every element, but I ran out of slide space, I guess. So question, is this an improvement for readability? Depends. I think if you try to widen the scope and see a longer test suite with the same repetitions going over and over, I think it does. For this toyish example, debatable. But generally speaking, I think it is. Okay, now for something a little bit more advanced. Evil product manager comes in with a new requirement. It must be possible to get notifications when we tried to order something that wasn't in stock, at least not to the extent that we wanted to, so we've been disappointed. And this should be an optional parameter, a std function parameter to add, and we want the implementation add to request the notification when the return quantity is lower than the requested quantity. Okay, add this extra parameter that we're not using yet, just to ensure that we haven't destroyed anything. Add a notify function and a convenience type alias. And I should slow down now because a lot will happen on these few next slides. So place a requirement that notify is called with open, and I cannot really do much with a callback to ensure that it is the right one when the callback is expressed as a std function. But I can say any, and then as a side effect, I can save that parameter, the function callback, in a local variable. So I use lr side effect to actually refer to this local variable so that I'm changing its value. Then I call add with a lambda that operates on another local variable, a lambda, a boolean that sets it to true. And since I'm adding 11 obans when there are only 10 in stock, I really should get this to happen. And to ensure things are fine, I call it and then I check that this local variable, this boolean called, is now true. This obviously fails because I haven't implemented it yet. But that is okay. It compiled, so we're on to something. I can add some things to the add function. So if the quantity returned was a disappointment, then I call the store.notify with a callback. So, hey, great. Shouldn't that have worked? It should have, shouldn't it? Oh. So the fix worked, but we broke another test. Oh, interesting. Okay. TDD works. We capture mistakes. Good. I can fix this easily, but let's take a step back and try to look at a bigger picture. This stock with reserve. It might be prudent to allow calls to notify as long as they are within the rules. That is not called with an uninitialized function. Did you know that you can compare std function with null pointer? If it compares equal to null pointer, it's a std function that does not call anything. It's default initialized. When we have tests where we really want to check things with notify, like the one we just wrote, we can have local deviations. Like I said earlier, it's it's a good idea, I think, to state defaults that works for most cases, and when needed, you say that in this context I want a different behavior. So we have a default that just checks that it plays by the rules. Just for completeness, a different way of doing exactly the same thing is to use a matcher. In namespace Trompeloeil, NE is not a not equal matcher. You can use it as the parameter. So you just say here, we allow calls to store notify with any whiskey and anything that is not equal to the null pointer. Trompeloeil has 7 matches: the not equal, equal, less than, less equal, greater than, greater equal, and regular expressions. You can actually, if you want to, you can negate a matcher. It doesn't make any sense whatsoever for the first 6, but for regular expressions it can actually be easier to say, instead of trying to invert a regular expression, it can be easier to say matches not this regular expression. So you just invert it with operator not, the exclamation mark. If you have really messed up your design, you may have overloads of this notify function with different signatures where the second parameter is actually equal comparable to null pointer. I have actually seen such programs, for real. If you have that, you can disambiguate the call and say, it's this one. When you need this, really think about your design. It's not healthy, but like I mentioned earlier, also programs with foul smells needs tests. So doing that, it still fails because we haven't done anything about the problem. But we have a different error message. We see that there was no match for this call with null pointer, but there was an expectation for another call. So, do you see the bug? It's on the highlighted line. We should only call notify when we actually have a callback that is not a default constructed one. So now everything is absolutely fine. So now it's time for me to wrap up because I don't have time to talk about more advanced stuff. Here's one thing, though. Trompeloeil has, if you go to the GitHub page, click on documentation, you will find a cheat sheet. The cheat sheet has, it's actually two A4 pages. Print them out, pin them to the wall next to your screen. And here we can see pretty much everything that I've talked about today. So you've seen how to use make mock and make const mock with a name and a signature and optionally an override to create mock member functions. You've seen how to use require call, allow call, forbid call, and also the named counterparts where you get a unique pointer instead of a local object that lives within the local scope. You've seen a brief introduction to in sequence. You can do a lot more with sequences than I showed, but you've at least seen it. And you've seen how to use .times to deviate from the default of being exactly one call for require call. You've seen how to use with and conditions to constrain calls that are otherwise wide open. And side effect to manipulate data and return to get values with any expression. I have not shown you .throw, but I think you can figure that one out. You've seen that in all these you can use positional names for the parameters, _1, _2, etc. And then the LR versions of them, local reference, where you manipulate local variables by reference. Here, beer dragons, be careful with lifetimes. I've not shown you very much of page 2, but you've seen the underscore matcher that matches absolutely anything at all. There is a typed version of it, the macro any, so you can say any int, again, if you have overloads that would be ambiguous with just the underscore. And you've seen how to use a not equal, and I mentioned disambiguating that one too, if needed. And I briefly mentioned that you can use the exclamation mark to invert a matcher. Unfortunately, I haven't had time to describe how you write your own matchers. It's not difficult at all. But given that I have 7 minutes left of this slot, there's not a chance I can do that. You can also actually, if your parameters to a call are pointer-like, a raw pointer, a unique pointer, a shared pointer, or anything with that can be dereferenced with the operator star, you can actually use matchers for that and say, star equal 5, meaning that this pointer, when dereferenced, must have the value 5. In the rare case when you need to have control of lifetime of objects in your test, for example, if you give your unit under test a mock and gives it ownership of it, and it is required to delete it at some point, you can use this convenience with horror movie time, Death Watch, and required destruction or named required destruction. Again, debatable if that is good, a sign of good design if you have that, but again, sometimes you need to test code that isn't great. This is not needed, but it is a convenience. It makes life easier. And that is pretty much it. I'm here all the rest of the conference, going home on Friday evening. Catch me if you want something. I can even show you how to write custom matchers, if you buy my beer. Here's where you find Trompeloeil, and here's how you can spam me should you want to do that. And there is time for questions if you want to. Then I say thank you for your attention, and don't forget to paint weird pictures for your programs. Thank you.